Hi there, and welcome to our lesson 4 in our final chemistry topic, C6 Chemistry Out There. And today we're going to be looking at alcohols and looking at the functional groups of alcohol. And we're also going to be looking at the preparation of alcohol and making a comparison between the methods of making alcohol. Anyway, I will see you at the end. Bye-bye. Okay, so here are our objectives for our lesson on alcohol. So by the end of this lesson you should know and understand the alcohol functional group, which will include the naming of alcohols, and how alcohol, which mainly is ethanol, can be produced by fermentation and hydration, and we'll also have a look at the comparison of the two. Alcohols have a really important use in various industrial processes. They can be used for alcoholic drinks, for solvents, for chemicals such as methylated spirits, and as a fuel in a car. Now, ethanol is probably the most common alcohol that you've probably heard of. Now, one of the main misconceptions is that it can be sometimes referred to as a hydrocarbon. However, it is not a hydrocarbon, as it contains carbon, hydrogen and oxygen as well. Now it has a functional group. This is the bit that does the reacting. Now the functional group for an alcohol is what we refer to as an OH. Now what we're going to do is go through a couple of the examples of an alcohol. Now the first one in the series is what we know as methanol. Now methanol has a structure where we have a central carbon atom with 1, 2, 3 hydrogens coming off, and then we go to our OH group that relates to it. Now if we were to draw methanol, then it would look like this. So we've got the central carbon with the 1, 2, 3 hydrogens, and then our oxygen and hydrogen as our OH group. Now if we move on to ethanol, we have our same OH group here, so there's the oxygen and there's the hydrogen. Now this time we have 2 carbons in our chain with hydrogens coming out either side. Now to draw the structure, it would look like this. So here is our OH group, we've got our chain of carbons and then our hydrogens coming off each one. Now as we move further down in the family, we have the next one, which is propanol, and propanol looks like this. So again we have our OH group, our hydrogen and oxygen, and then we go to 1, 2, 3 carbons in our chain, and then we've got the 1, 2, 1, 2 and 3 hydrogens going down off each of the carbons. Again, if we draw it, we've got our OH group and then we've got our 3 carbons with our 2 hydrogens coming off. So we've got the chain with the OH group at the end. Now the last two we're going to look at are butanol and pentanol. So we've got butanol with 4 carbons and pentanol with the word pent meaning 5. So again we've got our OH group and then we've got our 1, 2, 3 carbons for butanol, and then we've got all the relevant hydrogens on each of the carbon atoms in the middle there. And finally we've got our pentanol, so again the OH group, and then we've got 1, 2, 3, 4, 5 carbons in our chain, so the pent for the 5, and then we've got all the hydrogens, so 2, 2, 2, 2 and then 3 on the end there. Now there are a couple of ways of producing ethanol, but the most common way that can be done even at home is via fermentation, which you may have covered in some of your biology topics. Now fermentation uses yeast and sugar to ferment glucose, which is sugar dissolved into water. Now the reaction for fermentation is this. So we have our glucose, which breaks down to make 2 molecules of ethanol, which is this one here, and 2 molecules of carbon dioxide. Now fermentation takes a couple of days to actually carry out, and it needs to be kept at a temperature between 25 and 50 degrees. Now the apparatus used for this is shown here. Now here you have the water, glucose and yeast solution. Now that will be left for a couple of days at its optimum temperature. Now the enzymes in the yeast carry out the reaction to form ethanol from the glucose. Now what's also produced is carbon dioxide, which is allowed to escape, and you can test for that with the lime water here. Now a couple of things you need to consider. Now this thing here seals off the reaction vessels so that you've got an absence of oxygen, because if we have oxygen entering, then this reaction here with the glucose will be respiration, which will form carbon dioxide and water and won't form the ethanol. Now if it falls below 25 degrees, then the reaction becomes inactive. It no longer can actually start to react. However, if it goes above 50 degrees, then the enzymes in the yeast start to denature and it will stop the enzymes working. Now once you've carried out fermentation, you need to be able to extract the ethanol. Now this is done by a process called distillation. Now the distillation apparatus is set up here. Now within here you have the water and ethanol solution that you've made by fermentation. Now what you then do is you apply heat to it, and here you have a thermometer in this sealed round bottom flask. Now what the sealing will do is it will mean that the gas can't escape. So what you'll do is you'll heat this, and the solution of water and ethanol will boil when it gets to its various boiling points. So for ethanol it will boil at around about 78 to 80 degrees. Now when it gets to that point, the ethanol evaporates and turns into a gas, and this thermometer will read 78. Now up until that point the thermometer will increase in temperature. However, when it gets to 78-80 degrees it will remain there until all the alcohol has evaporated. Now because it's a gas, it's able to flow down into this container. Now, this is a Liebig condenser where you have cold water going in and then it comes out the other side, and it goes around the inner tube here. So you've got the tube with what is called a jacket going around the outside. Now the hot gas comes through here, and because you've got the cold water, it means that the ethanol will condense and it will drop down into this beaker where you have your pure ethanol. Now an advantage of this is it comes from sugar as a raw material. We're going to have a look now at another process to make ethanol. Now ethanol can be made by a process called hydration, and this is where you take a molecule ethene and you pass it over a heated phosphoric acid catalyst with steam. So let's have a look at the reaction. So we have our ethene molecule here, which you pass over the steam, which is a reactant. Now you need a phosphoric acid catalyst to be able to do this. Now this process is what we call an industrial process, so it needs to be carried out in an industrial situation. Now this is a non-renewable method of producing ethanol because the ethene, which is your starting molecule, comes from crude oil and from cracking that you will have covered in your C1 topic. Now we've looked at the two methods of making ethanol via fermentation and via hydration. What we're going to do now is just compare the two conditions. Now we'll look at fermentation first. First of all, it requires mild conditions, so it can be done at atmospheric pressure and at a slightly raised temperature of 40 degrees. It's a batch process. It's sustainable because the raw materials come from plants. However, it can take several days to actually produce ethanol. It requires purification via distillation, which requires more energy, which therefore means you have a low yield if the yeast stops working. Now the yeast will stop working when the alcohol levels get too high. Finally, because you produce carbon dioxide, the atom economy is going to be less than 100%. Now if we compare that with the hydration method, it's a continuous process, so you keep running the ethene over steam and the phosphoric acid to continuously produce the ethanol. There is little or no purification needed. As ethanol is the only product, there has 100% atom economy and therefore has a high yield. However, there are some drawbacks. It requires a high temperature and a high pressure. So therefore it needs more energy to be able to produce it. And because the raw materials come from crude oil, it means it's not sustainable. Okay, so that concludes our lesson 4 on alcohols, and just to summarise what we have looked at, we've looked at the functional group of the alcohol, which is the OH group, and we've looked at the chains, which are similar to the hydrocarbon chains that you will have done in C1. So we've got methanol, ethanol, propanol, butanol, pentanol, hexanol, heptanol, and so on as we go through the family. We looked at the two methods of preparation, so fermentation and hydration. We looked at the conditions that they're made in, so the fermentation is with a yeast enzyme, and then we've got the phosphoric acid at a high temperature and pressure for the hydration, and then we've looked at the preparation and how good they are compared to each other. Anyway, I hope you've enjoyed this lesson, and I will see you next time. Bye bye.